Hello, let's continue our Sudoku adventure with Circuitous by Chili. So this continues our Counting Circles theme week, where every puzzle has the counting circles constraint along with one other. So I hope you're enjoying that. Let's go over the rules to this puzzle. So we have normal 6x6 Sudoku rules. That means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. Note that in this puzzle, we have given you space to fill out digits on the outside of the grid, and that is for the little killer constraint that we have. But this is not technically part of the grid. But you are going to need to fill digits into these cells. All right, so, and the digits in these cells do not follow Sudoku rules. They're not part of the grid. They're just the clue that would normally go there. Hopefully that's clear. We do have counting circles. These circles count as counting circles. So we have all of these circles here. The way counting circles work is if you put a digit in a sounding circle, say a 4, then that means that there are 4 4s in circles somewhere. So we could do, say, this, for example. This would be perfectly legal. Except I think you might have trouble getting this to add to 4. But anyway, excuse me. So, if a digit appears in a circle, it appears that many times in the circle exactly. We also have little killer clues. Those are these, we don't have the digit yet. You're going to have to figure out what the digit is. But these clues, let's use this one, has an arrow attached to it. And that arrow points along a diagonal within the grid. And whatever digit is filled there, let's say we fill a 5 there, that means that these digits sum to that clue. So in this case, these would sum to 5. There is no non-repeat rule for little killer other than what Sudoku normally prevents. There's no additional non-repeat for little killer. And that's it. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay, first thing I want to do is, let's see, let's think about this first. So the very minimum that we could put on this diagonal is 1, 2, 1, and 1. So that's 3, 4, 5. So the minimum digit that goes in this circle is 5. Now, how many circles do we have? 1, 2, 3, 4, 5, 6, 7, 8. So we know that the unique digits in the circle add to 8. And the reason for that is whatever digit I put somewhere, like let's say I put a 4 here, we're going to end up with 4 4s somewhere, right? So if we have 4 4s somewhere, it's going to occupy, so whatever this digit was a 4, it's going to occupy 4 of the circles. So if we take just the unique digits, like let's say we end up with this, right? We filled them all. We followed the rule. The 3 used 3 spots and the 1 used 1 spot. If we add up the unique digits, 1, 3, and 4, that's going to add to 8 every time. Because if they didn't add to 8, we would not be filling all 8 circles. We'd be filling more than 8 circles. We wouldn't be following one of the rules. So that's still true even with these outside clues. So we know that the unique digit that goes in these add to 8. And we know that this is at least 5. Now what's interesting is, I mean, this could be as high as 7. I know that it can't be 8 because if this was an 8, then every single one of these would be an 8, and we've got quite a few problems with that. We know we have at least 2 unique digits here and here and here. So we also know that this digit is not the same as this digit, because if they were, then these would all have to be zeros because it's part of the sum, right? So this digit is at least 3 smaller than this digit if we were to spam 1s here. So if this is at least 3 smaller, I mean, I guess this could be as high as 7. This is 5, 6, or 7. Okay, but so there's an issue with 7, which is that some of these circles are in the grid. And if we did a 7, then all but one of them would need to be a 7, and that's no good. So this is definitely 5 or 6. Now, is 6 too many? So what would happen? So I can fill 4 6s here. I would still need 2 more 6s. They would have to go like this, because this has to be smaller than 6, and this has to be smaller than 6. So we'd end up with 6s here, but this given 6 prevents that. Oh, okay. I for some reason wasn't seeing this given 6. This given 6 says that we don't have 6 in our circles, at least not in 2 of the values of our circles. And if this was a 6, we would need to use these, because we can do 1, 2, 3, 4, 5, and then we can't put a 6th one in. So this ends up 5. So this is 1, 2. This is 1, this is 1. We can fill those with big. All right, we got some digits. Now, no matter what, we actually have another digit. because these only add to 6 or 7. We need to add to 8. So actually, we need to add to 3. So this is a 5, right? Because we know that our circles are going to be 1, 2, 5. We can't have 4 unique digits add to 8. And with 3 unique digits adding to 8, with one of them a 5, the other 2 add to 3, and that's only 1, 2. So we know that our circles are all 1, 2, 5. So let's fill that real quick, but we're going to be able to clean that up. So this 1, 2 pair tells us this is 5. This can't be 1 or 2 because these can't add to 1 or 2. So that's a 5. These definitely don't add to 1 or 2, so that's a 5. This can't be a 5 because it's part of a 5 sum. This also can't be 5 because it's part of a 1, 2, or 5 sum, but it's definitely part of a 5 sum. And there we go. So with all 4 of these are 5, this is a 5, and then we have a 1, 2 pair here. And so since this is a 1, 2 pair, it has a 1 in it. We can only have 1, 1 in circles. So this is a 2, and that's a 1. That's a 1, that's a 2. Okay. So we got all our circles filled. This 1 needs to add with 4 to make 5. This 2 adds with 3 to make 5. These need to add to 4. And the only way to add, let's see, we could be 2, 2, except neither of these can actually be a 2. So they're 1, 3, and we know the order because of that 1. Okay, and now I think we just finished the puzzle. So this is, sorry, I'll use this 5 to scan, and that is no good. I was like, what's going on? Why were there 2 5s there? This is a 3, 4 pair. Oh no, not 3, 4. Oh yeah, it is 3, 4. That's 3, that's 4. So this is 4, 6, and this is 2, 3, 5. This can't be 2 or 3. So that's our 5. We get our 2 and our 3. I think some of the red highlighting doesn't work in this one because in any row where we have repeated digits in the solution, it's not going to show you the red marks. Any row, column, or box. So you're going to get some of the red marks, but not all of them. This column needs a 1, so it goes there. This is a 6. These are from, in fact, we need a 6 in this box, which can only go there. And these are 4, 5. This 4 tells us the order. Got to be careful when scanning this. This is a 3, 5 pair. That's 3, that's 5. Down here we need 2 and 6. That's 6, that's 2. We get 4 and 6. I think we're just filling digits at this point. This is a 4. Here we do need a 3 in the column, which goes there. This is our 5. And then this is 2 and 6. We know the order of those. This is done. It's a 2. And then we have 4 and 5 left. And we're done. Very nice. Cool puzzle, Chili. I liked the idea of using circles on the outside clues to make little killers. That was really neat. I enjoyed the logic on that one. I enjoyed thinking about the circles and how we still had to make them add to 8, even though there were some of them not in the grid. That was a cool idea. And then forcing it to be 1, 2, 5 that way. I really liked that. Hope you enjoyed it as well. I hope you're enjoying Theme Week. And if you are, then why not leave a like, subscribe, and a kind comment below.